Hello, we are Group 27 and this is our project. Our client is the global luxury fashion retailer Net-a-Porter. The students involved are Vanya, Earl and Haran. Our project is about bringing the bespoke Net-a-Porter Extremely Important Person EIP experience to users by replicating the premium experience into augmented reality using the HoloLens. We are developing an application that allows users to browse through clothing available from Net-a-Porter and then visualize the clothing in augmented reality so the user can try them on by looking into a mirror and having the HoloLens map the clothing onto them. The user will be able to have an idea of how the clothing will look in real life. The application is being developed in the Unity engine and then ported to the HoloLens. Our key requirements are the ability to choose and try multiple items of clothing, shortlist items wanted so they are easily purchased on the Net-a-Porter website. We also need to have a quick and easy user interface that's streamlined by the use of voice recognition with the HoloLens. One of the main focuses of our research thus far has been creating 3D scans of clothing garments. We did this by firstly selectively choosing the perfect device for our suitability, which was the Sense 3D scanner. We also researched on the most appropriate AR or VR device that meets our criteria. For this, we chose to develop an application for the Microsoft HoloLens. The experiments that we did include doing HoloLens development tutorials available from the Microsoft Holographic Academy to get a sense of HoloLens development and its features, 3D scanning sample garments, and creating a basic UI in Unity. Aside from Unity and Visual Studio, we are also using Vuforia, a SDK for Unity, which enables us to create holographic applications that can recognize specific things in the environment so that we can attach actions on the specific objects. This is useful as our application needs to be able to recognize the user's body and morph the clothing onto it. For the proof of concept of our UI, we started off with rough sketches in a notebook that then evolved into these designs. They were done with the macOS software Sketch. The design was made for ease of use and clarity in the functions that the user interface provides. The first page simply shows our client and a search bar for the user to search for clothes. The next page displays the results so that the user can navigate easier. We used a page system with buttons to switch to the next page rather than a scroll. Then once the user has selected the different items of clothing that they want to try, the user interface will disappear and an example here is shown of the mirror and how the clothes are mapped for display. Once they've seen the clothes, they can select the ones that they want to shortlist and move on to the next page to confirm. After we received our 3D scanner a few weeks into the second half of the term, our focus was perfecting the scans. Here are some output of the scans that we did, and you can see the progression of the quality of scans as we learnt more about the correct techniques on how to scan objects. After some initial scans of a coat with a fur lining on its hood, we discovered that the 3D scanner is not able to pick up the fur, and that caused distortion in the image. When we decided to detach the fur lining, we got a near perfect scan on our last experiment. This is our proof of concept of the UI in Unity, before it's ported to the HoloLens. This is what it looks like when it is run in the HoloLens emulator. As you can see, it matches the first page of the user interface design, although with a different color scheme. This is one of the initial experiments that we did. We imported the 3D model as an asset to Unity and deployed it to the HoloLens emulator. This gives us a rough idea of how the clothing provided from Net-a-Porter can be scanned and displayed as a holographic object on the HoloLens. As you can see here on the emulator, the user will be able to use the gesture input to select the application and place it in the desired location. The garment that we have scanned will appear to be situated in the room that you are in. As this scene is built with the garment as a static 3D object, the user will be able to walk around the object and look at it from different angles. The user interface will move page to page normally via use of buttons or voice recognition on the HoloLens. It is in addition to the main phase of the application where the 3D models of the clothes are mapped onto the user's reflection. It might have a user interface during the phase, but very minimalist, only for crucial functions such as adding a piece of clothing to the shortlist. The system should allow you to switch between items that are the same category of clothing. For example, you can try on 2 different hats with the same outfit. The user might be able to see the clothing from multiple angles by turning their body. So far, we've done the requirements of the project and conducted experimental phases in conjunction with various research to conclude the method of use to provide this personal shopping experience to users. We've succeeded in obtaining 3D models of clothing by using a 3D scanner and then importing them into Unity. And we've set up a user interface to navigate through the application. For the next stages of the development, we are going to focus on the functionality of the 3D clothing and implementing user interaction with the garments. We would also like to add a sense of spatial mapping into our application so that it is more realistic and fits the brief better. Other features such as gaze, gesture and voice input will also be implemented to make the interaction feel more natural and intuitive.